Deep within the Earth, molten iron churns, generating a powerful magnetic shield, the magnetosphere. This invisible force field protects us from solar winds and cosmic radiation, making life possible. For centuries, the magnetic poles have been reliable guides for navigation, both for humans and animals, but this shield is not as stable as we once thought. The magnetic poles are moving and, their pace is accelerating. The North Pole, once steady in the Canadian Arctic, is now racing towards Siberia at unprecedented speeds. This isn't just a scientific oddity, it's a global event with real consequences. The magnetic field itself is weakening, especially in regions like the South Atlantic anomaly, exposing us to greater risks. Are we witnessing the early stages of a full magnetic pole reversal, where north becomes south? Such reversals have happened before, but never with a civilization as dependent on technology as ours. Understanding these changes is crucial. They affect our climate, our technology, and the very fabric of life on Earth. As we face this new chapter, we must ask, what does a shifting magnetic field mean for our future? For over a century, the magnetic North Pole drifted slowly about 15 kilometers per year, but in the late 20th century, it began to accelerate, now moving over 50 kilometers annually towards Siberia. This rapid shift forced emergency updates to the world magnetic model, which underpins all modern navigation. The cause? A dramatic change in the flow of molten iron deep within the Earth's core. A weakening jet beneath Canada and a strengthening one under Siberia are pulling the pole eastward. This isn't just a point moving on a map. It's a sign of deep, unpredictable changes in our planet's magnetic engine. Navigation systems, from smartphones to aircraft, must now adapt faster than ever. Scientists are racing to understand why the pole's movement has become so erratic. The accelerating pole shift is a clear signal Earth's magnetic heart is beating to a new, unpredictable rhythm. The magnetic field strength has dropped by about 9% in the last 150 years, a rapid decline in geological terms. This weakening isn't uniform. Some regions, like the South Atlantic anomaly, are far more vulnerable. Here, the field is so weak that satellites and spacecraft face increased radiation risks, leading to malfunctions and shorter lifespans. The anomaly is caused by reverse magnetic flux deep within the Earth, disrupting the main field above. As the field weakens, more solar and cosmic radiation penetrates our atmosphere. This can damage electronics, increase radiation exposure for airline crews, and affect atmospheric chemistry. The consequences are already real. Satellites are at risk, and our planet's natural defences are thinning. The steady decline of our magnetic shield is exposing us to the harsh environment of space. Scientists are closely monitoring these changes, searching for signs of what might come next. The weakening field is a warning. Our planet's protective bubble is not as resilient as we once believed. Magnetic pole reversals are a regular part of Earth's history, occurring hundreds of times over millions of years. The last full reversal happened 780,000 years ago, and the process can take thousands of years to complete. During a reversal, the field weakens dramatically, sometimes to just 10% of its normal strength, leaving Earth more exposed to radiation. Our ancestors survived past reversals, but they didn't rely on technology as we do. Scientists study ancient rocks and ice cores to understand how reversals affected climate and life. Some evidence links reversals to environmental stress, but the impacts remain debated. The past offers clues, but the next reversal would unfold in a world far more vulnerable to magnetic chaos. The shifting magnetic field is already disrupting navigation for both technology and wildlife. The world magnetic model now requires frequent updates to keep navigation systems accurate. Airports have had to rename runways, and directional drilling, mapping and surveying are more complex. Satellites passing through weak spots like the South Atlantic anomaly face increased malfunctions. Many animals, sea turtles, birds, whales, rely on the magnetic field for migration. As the field shifts, these species are getting lost, with more strandings and animals appearing outside their normal ranges. The cues they've evolved to follow are changing faster than they can adapt. This magnetic confusion adds to the environmental stress already facing wildlife. Both our technology and the natural world are struggling to keep up with the pace of change. The consequences of a wandering field are being felt now, not just in the distant future. A weakening magnetic field lets more cosmic rays and solar particles reach our atmosphere. These particles can seed cloud formation, potentially increasing global cloud cover and cooling the planet. But more solar protons can also destroy ozone, letting harmful UV radiation reach the surface. This threatens human health, crops and marine life at the base of the food web. Changes in the upper atmosphere can alter weather patterns, strengthening or destabilizing the polar vortex. The result? More extreme weather, from cold snaps to heat waves in unexpected places. The interplay between magnetic field strength, radiation and climate is complex and still being studied. But one thing is clear: a weaker shield means a more unpredictable climate system. The magnetic field's influence may extend to the jet streams and ocean currents that shape our weather. Changes in the field can alter stratospheric temperatures, affecting the path and stability of the polar jet stream. A more erratic jet stream leads to prolonged weather extremes, cold spells, heat waves and droughts. Ocean currents, like the Gulf Stream, are also affected by shifting wind patterns tied to the jet stream. Disruptions here could mean dramatic climate changes, especially for regions like Western Europe. While melting ice is a major driver, magnetic changes could add another layer of instability. Earth's systems are deeply interconnected. A shift in the core can ripple out to the air and seas. The magnetic field's instability is a hidden force behind some of our most dramatic weather events. The greatest risk is a full magnetic pole reversal, which could leave our planet's shield at just 10% strength for centuries. During this time, solar storms could cripple power grids and destroy satellites, threatening the backbone of modern society. Increased UV radiation would stress crops, marine life and animal migrations, compounding existing environmental challenges. Animals that rely on the magnetic field could face population collapses as their navigation fails. Human health would be at risk from higher radiation, especially for airline crews and frequent flyers. The last reversal happened before our technological era. Today, the stakes are much higher. Our interconnected world is more vulnerable than ever to disruptions from space weather. A full reversal would test the resilience of civilization in ways we've never experienced. Preparing for this possibility is no longer optional. It's essential. The magnetic field is changing now. Poles are racing, the field is weakening, and weak spots are growing. These aren't distant threats, they're present-day realities affecting navigation, technology and climate. While a full reversal may take centuries, the disruptive effects are already underway. Our infrastructure, navigation, communication, power, depends on a stable magnetic field. Ignoring these changes puts our society at risk. We must invest in research, monitoring and resilience to adapt to a more dynamic planet. The story of Earth's magnetic field is a reminder of our place in a living, changing world. How we respond now will shape our future in the face of this invisible but powerful planetary shift.